So we are the real-time machine learning group, and our project is facial recognition and mask recognition in real time. This is the team. My name is David Banyamin, and my partner is Nelusha Dias, and we're both students at Roper School of Engineering, majoring in electrical and computer engineering. So our objective was to try to find a project that fits the need to be running in real time and be using machine learning, and we chose facial recognition. Its main point was to identify faces in the frame in real time, as well as who is masked and who is not. And if they're masked, save them for later identification and try using facial landmarks. The second main part of our project was actually training the model and getting it to learn what a mask is. A very useful application that we thought would be appropriate for this project was to upload the program to a building security camera and have it scan people's faces and identify them and unlock the door for them the same way that a photo ID would work. Our timeline for the WinLab internship this summer was as goes. In the beginning, we spent the first half trying to learn all the basics. We needed to be able to do anything of the sorts because we were both very new to all these concepts. We spent the time learning basics of machine learning, Python, PyTorch, and hardware for machine learning, like the Jetson Nano that you see in the picture, which we used to run our program on. The second half, we started to test and create programs that were useful. So we created a basic facial recognition algorithm, and then we got it to be able to match names to faces, and then save and iterate through the phases it has on the database. And then at the end, we finally were able to build our own machine learning model and train it on masks.
So in terms of our project, we combined useful aspects of two programs. So one was a DoorCam project, which took a real-time camera feed for us, and it also helped us box and label faces. And another thing we used was facial recognition, which helped us put a name to a face. So our program specifically captures a frame of the live video feed, and it'll proceed to identify whether the person is known, unknown, or masked. And a section of the program iterates through known faces, and known faces are basically images of people that are saved into a file already. And once the person shows up in the video, if they're in the known faces file, then the video will add a box around the person's face and have their name there. If the face isn't in the known images file, it'll save the face and keep track of the visit count. And it counts as a new visit only if it has been more than 5 minutes since the person was last in front of the camera. So the video would then add a box around the person's face with the word unknown and the number of times that they have visited. We also used a convolutional neural network to create a mask identification system. So it would save the frame regardless of whether the person was known or unknown, and it'll figure out the top 10 people of who it could possibly be using the known images file. And every minute, the photo of a masked person is saved. So as I mentioned, we used a convolutional neural network. So the general idea of it is that it's a deep learning algorithm that can take an input image and it's able to identify what the image contains. So it does this by assigning importance to parts of the image, which helps it differentiate one type of an image from another. And in order to reach the identification stage, the image goes through layers, which applies filters, and these are able to transform the image into something that we can then use to identify what the image is. So for our program, we took in an image and transformed it into a tensor, which is basically like an array. And in it, each pixel is stored as a numerical value. So our program specifically uses two-dimensional convolutional layers, which would extract the high-level features from each image, as well as two pooling layers, which reduces the size of the result that the convolutional layers output. We also use 3 fully connected layers, which ultimately led into the image classification. So we used a learning rate of 0.001, which determined how much that we would change the model after each iteration. And we did 4 epochs, which means it ran 4 times with the training data, as well as a batch size of 4. So for our model, when an image is inputted into the trained model, it outputs true or false. So it's true if the person is wearing a mask, false if not. And if it is true, the person's image is saved, like I mentioned earlier. And if it's false, it goes through the regular facial recognition.
So this is a quick 3-example video demo of what our program actually does in real life. So the first demo is the camera reading 3 faces that we already have in our directory. and names each one correctly, as you can see. The second demo is of unknown faces. Here, the program does not recognize these faces, so it labels each new face with a new face and then the number of new person, and it saves the frame in a file and what number visit. If the person appears again after some time, it replaces the frame with a new frame and the number of person and which visit it was. So like visit 1, visit 2, and so on. And the third demo shows the program recognizing that there is a mask on the person in the frame and labels the person as mask 1 and saves that image. And then if another new person with a mask comes on, mask 2, and then saves that image as well. And this is our poster that we made for the project. And this is our website if anyone wants to further check out our project or any of the programs that we have written. And the link is right there.
The results of our project was that we got a functioning program and it identifies the person in front of the camera if they are in the database. So it'll save the unknown images and it'll also save masked individuals into a separate file. So in terms of improvement, we could improve upon our convolutional neural network by adjusting the numerical parameters, by adding and removing layers, and changing the loss function, and this would hopefully make it more accurate. So we could also adjust the ability to read a masked face, because as of now, if the mask is not tight-fitting, it's hard for the program to identify that there's actually a face in front of the camera. We would also like to improve upon the ability to read multiple masked faces, because as of now, it will only read one face at a time. So for our project's potential use, we could use it as a security camera. So it would save unknown people when they're trying to come into the building, as well as keep track of how many times they've come. Another use is that it could help ensure that people are wearing their masks before entering the building. These are our references. And thank you for listening. Are there any questions?